Good evening, everybody. If you can hear me, let's get started with today's class. If you have any doubts, let me know. So far what we did was we started creating a table and then, we went to insert some data, delete data, update data. We also did a lot of selection of data, like select using different clauses. We altered the table by adding new columns. We also modified the existing columns. Um, we created tables as query. We inserted data using a query. We did drop table, rename tables. We talked about dual and tab special tables. We talked about a lot of functions, null value function, decode, numeric functions, or number functions, character functions. We talked about date functions, then conversion functions, like say converting a date to a character or a number to a character, to number and to date. We also talked about group functions like max, min, sum. And also we saw how to use these group functions in a group by clause in select statement and having to filter the group results. So we covered a lot of stuff, but right now what we'll do is we'll go back to the basics of creating table and we'll talk about constraints. So far, we did not put any restrictions on how the data will be inside the table. Constraints are the best way to implement rules. Um, some of the basic business rules, let's say, for example, anybody who is a student, let's say in our university, age should be less than 40. Above 40 people should not join our university, or they go into a different program, so they should not be going into certain table. So how do you implement such restriction is using constraints. So what we'll do is we'll take an example of, let's say, customers table, and we'll create the table. And while creating a table, we'll put all kinds of constraints and restrictions and see how to use this table when we are doing, like say, customers will buy products. So how can we use these constraints? Okay. So first thing what we'll do is, let's just type create table customers. Okay. Customers. So this is the table we'll create today. And what we'll do here is, let's say, what is the first column you would like to have in the customers table? Let's say customers table will have customer ID. That's how we'll identify a customer. Um, so whenever customer logs in, we have an internal ID stored and it can be a number. So let's say customer ID underscore ID is a number. Okay. Now, as soon as you have a number, what you can do is you can specify this as a primary key. Okay, so primary key is the constraint here. So what is happening here is, like, if you notice, what we are telling with the primary key is customer ID is the primary key, and whenever there is a primary key column, basically this cannot be repeated. Meaning, if you have a ID 10 assigned, that 10 cannot repeat again. And also internally, primary key is compulsory. It is a required mandatory column. Value wise, you cannot avoid providing value. You have to provide value for this. So that is the first column. So you already know the column name and the data type. So only thing new here is we introduce something called primary key as a constraint, meaning when you're inserting data, it will check for customer ID. If it already exists, it is going to throw an error. If you don't provide, it is going to throw error because it's a mandatory column. Okay. What we'll do is we'll create this table and then put some data in. While doing that, we'll check all the different constraints and their functionality. Now, each customer will also have customer name. So let's just do a customer name, and it is a varchar, um, let's say 20 characters. Okay. So let me push this away a little bit. Now, what we'll say is, for example, every customer should have a name, right? Without the name, we don't want to accept any entries. So how do you implement certain limitation? Like, so for example, okay, you have to provide value for this column. You cannot provide me null. So we will say not null is the constraint we are going to implement for this column. Okay, that means customer name is of varchar 20, and you have to provide value while inserting data. You cannot say, okay, I don't know the name, just put null. That will not work. Okay. Now let's say every customer, when they log in, they will use something like, say, for example, email ID. Okay. So customer email is, let's say, varchar of 50. Because emails can be long. So I'm just saying it is a 50 character name. Okay. Now, can email be null? Yes. So we can say, for example, okay, I will accept nulls. And also, I'm going to specify another constraint here, second constraint called unique. Okay. Now, what does unique mean is this particular column will allow nulls. Okay. So meaning you can, this is not a mandatory column. Customer email, probably we don't know. Sometimes, like say if somebody calls by phone, we don't have the email ID. So imagine you don't know the email ID, so it could be null. But if we know the email ID, then it has to be unique, meaning you cannot have two customers have the same email ID. Okay. That we don't accept in our system. Now, this is according to your business rules. Okay. So unique constraint will not allow duplicates, but it will allow nulls. And here we specified that customer email can be a null, but if you provide some email ID, that has to be unique across all rows. No two customers can have the same email ID. Okay, now let's say customer um, age. Okay. Now, customer age is of number 2 because you don't want to accept, let's say, okay, let's put 3, okay, and that means it can go from 0 to 100, I mean 0 to 999, 999, okay. But we know that age is valid, like, we want to have customers who are, let's say, for example, above 20. This is our business rule. Okay. And customers should be below, let's say, 70. Okay. So we don't sell products to anybody more than that or less than that. Okay. So that means you have to implement a constraint called check. Okay. Check constraint. Now, how are we going to implement check constraint is, say, for example, in the brackets, you will write the condition for this check constraint. Okay. Now, condition is customer age should be between. Okay. We looked at between when we talked about select statement where clause. Here we can use between. Let's say, what did we say? 20, age above 20, and so here 20 is included. Okay. So anybody with age exactly 20 will be accepted. Okay. And they should be less than 70, less than or equal to 70. 71 will not be accepted. Now, by doing this, we are implementing a check constraint on age, saying our business only allows people who are in between 20 and 70 years age. And in another way, you are also avoiding any negative values coming in, because you know that number 3 can, sorry, numbers can be negative or positive. But here, by putting a check constraint, we are making sure we are getting only valid data. Now, why do we implement constraints? Is to have validations on the data. If you don't have this, your data can be junk. meaning anybody can come in and put any data and you will not have any validation on that. So what we'll do here is, now let's say, for example, um, so we got customer ID, customer name, email, and customer age. Okay. So for now, let's just go with that much. Okay. Now what we'll do here is we'll see how we created this table. What we'll do is to review what constraints we used here. Okay, so let's start with the null and not null constraints. So here, customer name is not null, meaning it will not allow null values in this column. So it's the simple, straightforward constraint called not null. But there is another constraint called null where we are saying customer email can be null. Okay, so I can accept nulls, no problem with that. Now, we also implemented another constraint here called unique, and customer email is unique, meaning in this table, in the customers table, no two customers can have the same email ID. So we'll reject the second email ID when it becomes same. So we are implementing that unique constraint. Then looking at the primary key is a combination. If you think of primary key is a combination of unique key plus not null key, meaning it will say I will not allow nulls in this column, and also I will maintain the uniqueness, meaning you cannot have a repeating number. Every customer needs to be identified with a specific number, and that number cannot be repeated, obviously, for obvious reasons. And then we implemented here a constraint called check constraint. So we have this customer age. According to our business, we are not going to sell products which are like, say, products when the age is restricted to certain limit. So what we did here is we are checking for age between so and so. Okay. Now uh, here you can see these are all written at the column level. There is something called table level constraints. So what we'll do is first let me introduce this at this level, and then I will put one more. We'll create one more table, products, where we'll create much more detailed syntax. Okay. So here, let's just run this, and you can see the customers table got created. Okay, table customers created. Now you can expand this in the developer, SQL developer, and you can see that you have all these different columns. You can click on the customers table, and here you can see there is a tab called constraints, and this will show you all the constraints you have implemented. There are different constraints, and all the constraints are implemented inside. What I want you to notice is you see this constraint name is auto-generated. You can actually name this. When you go into production, you basically want the names to be like, self-reading or a better naming instead of having system names. So what we'll do now is just close this. Now we understood how to create customers table. What we'll do is we'll create products table, but use a little bit different syntax. Okay. I will introduce something called constraint name and stuff like that. And also remember here at every column, we specified what is the constraint for that column. Okay. Now these are all constraints defined at the column level. I'm going to introduce something called table level constraints. Okay. So let's say, for example, we'll create a table called products. Create table products. Okay, now this is a simple table where we are going to have some products we are going to sell later on. So first of all, we need a product ID. Okay, product underscore ID. So any business needs a product ID. Any business needs products to sell, and we have to identify each product with a unique number. So we'll say product ID is a number. Okay. Now here I'll just specify that it is a number, and I'm not going to accept nulls for this column. Okay. So I'm just specifying it as not null column. Then next thing is product underscore name. Now, obviously, you know that this is a varchar column. Let's say each product can be of 50 characters length name wise, and each product for sure you need name. Okay, so you will say not null. Now, what we can do here is at this level, you also know that there is a price, product price. Okay, what is the price for the product? Let's say, for example, it is a number. We'll say data type is it can be 5 digits with 2 decimals. Okay, so here it is going to accept what is the maximum value it will accept is there will be 5 digits and 2 decimals like that. Actually, let's make this 7. So there will be five integer values and 2 decimal values. Okay, so that will be the max it will accept. Then also make the product price, you should never have 0, right? It should be always more than 0. And you cannot have a product price which is negative value. So you can have a check constraint on this. Okay. Now, check constraint is always written at the column level, but you can also have, like, say, for example, you can have it at table level. So I'll just say, for now, I'll just say comma, and then now let me introduce what is a table level constraint. So what we'll do, instead of defining constraints at the column level, after providing all the columns, we'll start writing our constraints. So here, constraint constraint name. So constraint name is, let's say you follow a specific naming convention. Let's say primary key will be PK products table, primary key for products table. Okay. Constraint name, and what is the constraint you're defining? Let's say primary key is the constraint. Now here you also have to tell what is the column which will act like a primary key. Product ID is the column which will act like a primary key. Okay. Now that is your first constraint you define. Now next constraint, let's say product price. Okay. Product price should be always more than 0. So let's say constraint constraint. Okay, let's take a product name and make it unique. Okay, so let's say UNQ unique. Okay, product table, products table, and what is the column is product underscore name. We are going to make this unique, and what is the column name which becomes unique is product underscore name. Okay, now here don't confuse the constraint. The second word here is a constraint name. Instead of generating the constraint name by system, you are actually naming it by providing your own name. Let's say, for example, you will say UQ for unique. Okay, and you're telling what is the constraint and what is the column which is having that constraint. Now then last one will implement a check constraint. So constraint name is check. So let's say CK, and products is the table. That is your naming convention. And what is the, let's say what is the product price is the column name. Okay. Then what is the condition you're implementing is the check condition. And what is that you're checking for? Okay. So what is the condition you're checking for is product price should be always greater than 0. Okay. It can be $1, but it has to be greater than 0. That is the condition you're implementing with this. Okay. So now if I run this command, I'm going to create the products table. And what we did here is instead of defining constraints along with columns at column level, we defined them at the table level, meaning you first provide all the columns in the table and then start providing all the constraints for that table. Okay. So these are two ways you can define your constraints. There is one interesting functionality like say dependencies. Now we are working on RDBMS. RDBMS means you can relate tables. There are tables where they depend on the other tables. So now here what we did is we created a master table which will contain data for customers. We created another master table which contains data for products. Now let's say when you go to sales, you are going to sell these products to the customers. So you will actually have the relational table, which will be a dependent child table. Okay. Let me use a small drawing here just to explain how this will work. So let's say, for example, I will use paint for showing you what we are trying to do here. So let's say, for example, I will draw like there are two tables, let's say blue color. Okay. So this is our customers table. This is our products table. Okay. Just to know what they are, like we can put some text in there. So this is our customers table, and let me make this like say bigger font. And this is our products table. Products table. And you can see they are at the master, like they don't have any dependencies. But let's say when we come to selling, let's take this color and take another box. Now this particular table is our sales table, let's say. Now what sales table does is um, sales table depends on both of these tables. So what it does is sales table has columns like say what is my product ID and what is the customer ID, customer underscore ID, who purchased this and what was the total total price. Okay. And you can also keep some quantity here, quantity QTY. Okay. Now, and also you can have like say sale date, when was the sale date. Okay. And other columns. But what is most important here is you can see how this table depends on customers and products both is based on this relationship. Like say for example, the product ID is related to this table, and same way you can see. Um, Let me draw another line which will go like from customer ID is related to customers. Okay. So this is just a representation to show you that there are relations. Now these are master tables, like you can see here. Um, Let me just note them. These are master tables. Tables. These are master tables, and then there are child tables. Child tables, or actually let's say master or parent here, because you can call this as a parent also, parent or master. And here it is child or dependent tables, dependent tables, or this is just a table here. Okay, but you can have multiple tables. So now, because it is RDBMS, RDBMS actually says that you can define relations, and this is where the relation comes. Like, when you're talking about relation, this is the relation. Now, how the dependent table relates to their masters is the relation. That is what R stands for in RDBMS. Okay. So RDBMS, most important thing to note is this R is the relation. So how do we create this relation is using a foreign key constraint, okay, primary key foreign key constraint. So what we'll do is we'll create the sales table and see how to use how to create table using these constraints. Okay. So what we'll do here is let's create another table, and what we'll call it as sales. Okay. Create table sales. Now, what are the things we need to identify sales? Let's say we already wrote this before. So first of all, what we need is who is the customer who is buying it? Okay. So customer underscore ID. So customer ID comes from this table here. So customer ID is buying something from us. So that is a number. Customer ID is a number. You can look at the other table. Okay. Now, what you will see here is customer ID is a number and we need to know the customer ID, right? So I will say not null. I cannot have this as unknown. Same thing, I will say what is that customer purchased? Product underscore ID is the product he is purchasing, he or she. It's a number. And also we cannot have unknown product purchase. So we'll say we need to know the we need to know the product which was purchased. Okay. Now, uh, so how much quantity was purchased? Okay. QTY, purchase quantity. Let's say purchase quantity. And you can see this is just a number. And we can say how many quantities were purchased. Um, this is a not null again because you want to have people purchase at least one item. You cannot accept unknown values. So we'll just put it that way. If you want, you can go further and say check constraint, check that um, purchase quantity. This is all depends on your business again. Purchase quantity between. Okay, we will sell only 1 to 1 and 10. Okay, we'll not sell more than 10 pieces to any given person. Let's say this is a good sales and we don't want to sell too much. Okay, so that's our business rule. So we implemented a check constraint for that. Then let's see what else we need. What is the total price? Okay, total price for this transaction. So let's say, for example, total price is a number. We'll just leave it as, let's say, anybody can pay us a lot of money. Okay, so I'm sorry, 9 comma 2. That is a lot of money and it cannot be null. Okay, so we'll just make it not null. Having good constraints is a good strategy. That means you will have data validated before putting into the table. There's always a good idea to have good constraints. Now you also need to know what was the purchase date, right? Now without this purchase date, how can you tell when was this purchased? So this is a date column. Okay. Now you also need to know the date. So I will make it not null, meaning we cannot put a null in the purchase date column. Now we are done with the columns here. Now let's start defining some constraints. Okay. So first of all, I want to introduce to you a constraint here called a primary key. That primary key was just put on one column, which is a simple primary key. But sometimes you cannot put a primary key on a simple column. Let me show you what I mean by that. You can obviously write constraint name. I'm going to ignore that and I will say primary key. And let's say if we put a primary key constraint on customer ID, okay, what will happen is you know that you cannot repeat, it will not allow you to repeat the customers, meaning if you sell a product to the customer, that customer cannot buy anything else if you implement this primary key. Okay, so that's a bad strategy, right? We want people to buy more and more from us. We don't want them to, not buy from us. So just having customer ID as a primary key is bad. So what do we need to do is, let's say this customer can buy one product. Okay, here, let's say product ID. Now I included two columns as a primary key. So what does it do is each customer can buy one product only once, right? This combination should be unique. It cannot repeat, meaning customer buying milk cannot buy milk again, right? Probably this is not a good idea because when you have a customer trying to buy milk, he can come back after 1 week and say, I want to buy milk again. So you cannot have this kind of restriction for business. It's not good. Okay. Now let's come up with one more column here, which might make this unique by adding a purchase date to this transaction. Now let's say we are online business, let's say Amazon. I don't want my customers to buy the same product twice on the same day. Okay. So this particular combination says me, I'm buying iPhone, uh, and I cannot buy that iPhone on the same date again. Okay. Now, if you go beyond this and think of it, date will also accept time, right? So let's say, for example, a customer cannot buy iPhone at the same date and time, second time. Okay. Like say at 10 o'clock he can buy, and then at 10:30 he can buy one more. So maybe this constraint is pretty good, but you have to understand your business properly and then implement this rule. For now, I just wanted to show you how to use multiple columns in a primary key, and this is called composite primary key. Now what is the difference between previous one and this one? Previous one had only one column in the primary key. Here it is a composite primary key because it has three columns in the primary key. Okay. Now that so far is good, right? Now let's say, how would you implement a restriction saying customer should exist? Before buying, this customer should be already there in the customer's table. Now how can you implement that restriction is using a foreign key. Okay. So what you will do is, let's say primary key, sorry, this is a foreign key implementation. So foreign key, foreign key. Now you can also write constraint name fk underscore sales underscore customer. Okay. So foreign key. Now, first of all, what is the foreign key column? So customer underscore ID is the foreign key column. Now, you know that it is a foreign key, meaning this column actually is coming from somewhere else. It is coming from customer's table. So how would you reference is, how do you say, okay, before you put data in here, it should refer to something, right? References. Now, what is that it references to? This column is referencing to the table customers. So we'll say it references customers table. And what is the column it is referencing to? Okay. So let's say this is referencing to customer ID, meaning what we are telling here is I'm going to accept only customers who already exist in the customers table. And because this column is coming from somewhere else, I'm telling that it is a foreign key. It is not local to here, but it is foreign key. The value is coming from somewhere else. Now let's say products, right? You don't want to sell products which are not existing. So that means you want to check products existing in the products table. So you can do the same thing again. So let's say, for example, I'm not going to define the name of the constraint. I'll just say foreign key, REIGN key. And see that I'm using mixed case. It doesn't matter whether you write uppercase or lowercase. What is the column which is going to be the foreign key here? So I'm talking about product ID now, and it references what table? Products table. So you can see here this is a products table, and what is the column in the products table? It is referring to product underscore ID. Okay. Now that is specifying. Um, So actually here we specified everything we need. We said what is the primary key, what are the two columns it is referencing to, and all the stuff is in place now. Okay. So let's create this sales table. So let me just say run, and it's going to create the sales table. Okay. If you really, if you plan properly and understand all the syntax, see how I'm able to write one command without any error it is running, because I understand the syntax properly. So, and also before you run, check it twice so you know that you're running the right command. Let's talk about one more scenario where there is a dependency. Now what I want to introduce is the customers table. You see how I did not store any address or the phone numbers? What I want to do is I want to collect the addresses and phone numbers because each customer can have multiple phone numbers, multiple addresses. So what we'll do, let's say we are going to collect, let's say, phone numbers because each customer can have multiple phone numbers and there is no restriction, right? A customer can have 10 phone numbers. So what we'll do here is we'll say what is that we want from the customers table. So for the dependence of the customers table, let's say create table customer underscore contacts. Okay. So this is where we are going to store our customer phone numbers. So what we'll do here is obviously we want to identify the customer and we'll say customer underscore ID is a number. Okay. Now I need to know the customer ID. So I'm not going to allow nulls. So I will say not null. And then we'll say, what is the phone number? Okay. Phone underscore number. Now, because we talked about phone numbers earlier, you can put international phone numbers in there. So I'll just make it 20 characters long. So you can put international formatting and stuff. And I'm not going to allow nulls. Okay. Now this is known syntax, but what I want to do is now each customer can repeat. So we are not going to put any primary key, any unique key or anything, but this customer ID should exist, meaning there should be a check for customer ID. What if we just copy this constraint called customer ID constraint? So let's just copy it here. I'm not going to name it, so I'll just delete. So ignore what I did there. So I will just remove this part. So let's say foreign key is customer ID and it references customers table. Now we also want to do something like say, I will specify something here on delete cascade. Okay. Cascade. I will tell you what it does. Okay. So I'm introducing one more functionality here called on delete cascade. First of all, in this table, customer contacts, the foreign key is the customer ID. It references the customers table and that customer ID should already exist in the customers table. That's the restriction you're implementing. What does this on delete cascade do is, so you know that you have a master table customers. Let's say here you have the customers table and then you have sales table, right? Sales table is the dependent table. What happens when you delete a row from customers table? Let's say, for example, you're deleting one row from customers table. All the dependent records for that customer you're deleting, what should happen to those? Okay. Now in this case, they will all stay and also it will not allow you to delete this. It will give error. Okay. I will show you when we do some practical on that. But what I'm doing with the on delete cascade functionality is if at all you're deleting a customer, all the records related to that customer from the dependent table should be deleted. I'm telling if at all you're deleting the master record, then delete should also take care of cleaning up the customer contacts table. That's what I'm specifying with on delete cascade. Okay. So let's just create this table. And then what we'll do is this customer contacts table is also created. We will play with this data to see restrictions, how they're implemented and all that. So any questions so far? What we'll do now is let's put some customers data inside and we'll play with all the constraints. Whatever constraints we implemented, we'll check whether how they work. Okay. Now insert into customers table, first one. Now I will say, what are the values? Okay. I'm just going to specify values. I will say first one is my customer ID is 1001. Okay. So you have a question about on delete cascade. What we'll do is we'll put some data in, we'll play with the data, and then I will explain what is happening with the on delete cascade. Okay. So let's play with this data first. So let's say, for example, now we have to provide the customer name. Let's just say I don't know the customer name. I'll say null. Okay. And then what I will do is, what is the email ID? So let's say, for example, email ID is something, sarma@gmail.com. Okay. So that is my email ID. And what is the age? Okay. So age is, let's say, 40, which is allowed range. If you look at our range, it is allowed. Okay. So now let's run this command first. And what I want to show you is there is an error. Okay. So what it is saying is cannot insert null into Scott customer's customer name. Okay. Why that is coming is, you see how we implemented a not null constraint for name, and we are trying to put null in the name. So that's the reason it is giving error. Okay. That means if you implemented your constraints properly, all your data will be validated when somebody is inserting data. So this is a very good check. Now I'm not going to allow nulls. So I will say, okay, let me fix this. Let me say name is Sarma. Okay. So now we'll run it, and then one row got inserted. Okay. We'll check the row later on. Actually, we can check that right now. Select star from customers. So now what happens is you run it and you see the data exists. Okay. Now what we'll do is we'll try to violate our primary key, because now let's say you are getting the second customer, and second customer also is the same ID. Let's try to violate the primary key and see what happens. And then let's say, for example, because we know that name is there, I'm going to give a name which basically is little different from the other one. And also email ID is also different. Okay. So we are fine here. But what we are trying to violate here is the primary key. So let's see what happens when we run this command. What happens is you get another error here. If you notice, what it is saying is unique constraint violated. Okay. Um, Basically, what we did with the constraint is here we specified the customer ID as primary key. Internally, what it does is it creates a unique constraint and it creates a not null constraint on that particular column. But in any case, it is telling you that it is violating one of the constraints. I'm not able to insert because you're providing the same value here. Oh, by mistake. So let me correct this. And when I run, it will basically allow that insert. And now I got two rows inserted into the table. Like if I select the data, you can see two different rows. Okay. Now let's try to violate some other condition here. I want to show you the unique constraint. So let's say, for example, I have another customer coming in, but telling me that they have the same exact email ID as some other customer. Okay. So name is something like, let's say Ravi. Okay. And but email ID is exactly same as the other customer. So when I run this, excuse me, it tells me that it is violating another unique constraint. Okay. Now see how it says this something. We don't know what is the name. If you look at the other names, like say for example here, we defined proper names like here. So it is going to tell you what constraint it is actually violating. That is the use of naming a constraint. Okay. So for now, how do we fix this? We know that it is, you cannot have a duplicate email ID. So we fix it. Okay. But now let me violate the age. So let's say, for example, I want to make it, let's say 10. Age is 10, and I'm trying to register myself. Here it says some other constraint is violated. Okay. Obviously, because names are not well defined, you cannot identify. But obviously, it is telling you because of age, the check constraint is failing. So you can see here very clearly, it tells you that check constraint has been violated. Okay. So let's fix this. Let's say 60. And then when you run this, you're going to have three customers. Okay. So now we have three customers. One, two, three. Okay. So now let's go to the next part where we are collecting the phone numbers. Let's say insert into customer contacts. Okay. Values. I'm going to provide the customer ID 1001, and what is the phone number for that customer, right? 987 654 3210. That is the phone number we want to provide. Okay. Now let's just run this and you can notice that I got one row inserted, and let's also select to see select star from customer customer underscore contacts, and you can see that one row got inserted. Okay. Now let's put one more row and then we'll violate the foreign key. Okay. So let's put one more row here. I'm just changing very simple number. So we have the second number for this contact. You can have multiple rows now. That is possible. Okay. Now what we'll do, we'll try to violate this constraint. Let's say somebody else comes in and the customer ID is 1010. Okay. And when I run this, let me clear the screen. Okay. Let me run this command and it tells you integrity constraint so and so violated, parent key not found. Okay. It is telling you that the referential integrity is violated here and the parent key not found. See how 1010 does not exist. When we created only 3 customers. The 1010 does not exist. Okay. So, oh, this is wrong. So let me fix it. 10, I'm making it like another value. Run that. So we also check the foreign key, how foreign key works. I'm going to talk about on delete cascade a while later. Let's just put some values in. So each customer has some contacts now. Okay. So you can see here each customer, like say first customer has 2 contacts, second one has only one, third one has one. Let me actually add one more for the third one. I'm going to keep all the insert statements here. So later on we can play with this data. Okay. So now I inserted one more row. Ignore this error message and let's look at the contacts again. So let's see what happened to all the contacts. Now you have two entries for the 1003 customer. Okay, so now let's go create products. Okay, products, we already know all the conditions. So what we'll do is we'll just blindly put some product information in there. And what we'll do is insert into products, values. Okay, I will just put one product and we'll be able to sell that product. So let's say product ID is 1. Okay, product ID is 1. And what is this? I said milk. That is what we are selling. And what is the price? Let's say $2.75. Okay, so that is the only product right now we are selling. And now if you look at select star from products, you can see that we have one product and we can sell that product. Okay. Just for easiness, let me put one more product here. Let's say the second product is bread. Okay, you want to check here something. There is a unique constraint on product name. What we did is we created a product name unique constraint. So let's put milk again, second one, and we'll say this is $4 or 5.25. That is the cost of the milk. Let's say 2 pieces I'm selling for sale, right? Let's say run this. Now, if you notice, it clearly tells you this is the constraint which got violated. Okay. Now it tells you unique constraint, UQ in our naming convention stands for unique. It is on the products table. This is how you identify the table name, and product name got violated. And then if you continue to read, it says unique constraint violated, meaning it clearly is telling you that milk is not allowed again. Okay. So now let's fix this. I was going to write bread for product and then run it, and then also look at the products. We have 2 products. Okay. So we verified all the different constraints so far. And also let's go to the last one. Okay. Let's say for example, sales. Okay. Now what I will do is for selling stuff, I will say insert into sales. Okay. Now, what are the values we can have for sales values? First one, we need to know what is the customer ID. Okay, customer ID, I will say 110. Okay, I know that that particular customer does not exist. I know that, but I'm just going to put it so we can test our foreign key error. Okay. Now then the products. Let's say he's buying milk. Okay. And how many milk is he buying? Let's say purchase quantity is what is the purchase quantity? Let's say only one for now. Okay. And then what is the total price? Let's say I gave him discount. He's going to pay only $1.50. Okay. 1.5. And then last thing it is asking me is the purchase date. What date I purchased this. So remember yesterday we talked about dates, and let's say this transaction happened on 25th January. I'm just making it look like the format what we know, and let's say close this. Okay. Now, first of all, when I run this, it is going to throw an error called foreign key sales customer has violated and parent key not found. You can see that this ID, which is referring to the customer ID, does not exist. Only 1001, 1002, 1003 are the valid customers. So let's fix this. It was a mistake. It was 1001. Now, second one is a product ID. Let's do that one more time here. I'm going to use product ID 10, which does not exist, and then I'm going to run, and it is going to give you another error saying parent key not found. Okay. So you can see here, this is your named constraint, which helps you identify the error. Here it is named by the system automatically, because what we did here is we named it for customer ID, but whereas for product ID, we did not name it. Okay, hope that is very clear. So now let's say he's buying milk and I'm going to give him complete discount, zero. Let's say he's paying $0. Okay. Now let me clear the screen and run it again. And one row got inserted. Okay. Oh, we didn't put the check constraint on price. Okay, we did not. So that's why it got inserted. That's okay. We lost some money here. So let's select star from sales. So what we did is we checked the foreign keys and all that stuff. And the sales happened, right? Some price and quantity, whatever. So you got all these things taken care of. Now remember, one customer, he can buy the same product on the on a different date. He cannot buy it on the same date, right? So what if we do this exact combination one more time, but now he's going to pay, because he missed paying us earlier, he'll pay $5 now. Okay. So let's run this. And what happens is there is a violation on the unique constraint. Now, what was the unique constraint is we are saying same customer, same product on the same day he cannot purchase. Here you can see that same customer, same product on the same day. Okay. This 25th Jan. So let's make it look like he is not buying it on the same date, but let's say he's buying at a different time. Okay. So you remember to date function, and what we did with the to date was we will say 2016, whatever we want to type, and also we'll specify the format for this. And also let's say, for example, he purchased this at 1 o'clock, 50 minutes time. And what we'll do is here we'll specify so DD MON 4Ys. So yesterday we talked about this. Now we are using it HH24 and MI for the minutes. Okay. So I'm specifying what date it is. Now you can see that one row got inserted because now it's a different date on different date and time, meaning even though it is the same date, time is different here. Okay. So obviously it allows you the second time. Okay. Now it satisfies your business rules. So, so far I hope we are good. We explained all the constraints. What we did not explain is what is this on delete cascade. Okay. So let's talk about this on delete cascade. Okay. Now what we'll do is let me open another window similar to this. Okay. So let me see if I can, how do I open another window? Let's say, let's open another window, open SQL worksheet. Okay, here. So here what we'll do is select star from customers and also select star from customer underscore contacts. Okay. let's run this as a script. So what you see here is the output shows you that we have 3 customers. Okay, let me do this again. Let's see if we can get this output again. Okay, so you see the customer email, age. Oh, okay, I see what's happening. So let's not get the whole thing, but what we'll do is we'll just get the customer underscore ID, customer underscore name. Okay, and for contacts, we'll just get everything. So we'll just clear the screen. Okay, so what is happening in the output? You can see here we have 3 customers and their names. Each customer has some contact numbers. Okay, now your master table is customers and your dependent table is what you say, like the dependent table is the customer contacts. There is one more table called select star from sales. Okay, now what we'll see if we run this particular thing is you see that every customer has also done some sales here. Only 1001 is the customer who did some sale, purchases. Okay, so let's say customer ID, and let's say what did he buy, product ID. Okay, and also let's say distinct, just to get only few rows, right? We talked about all those before. So now we know that this customer has done some purchases and also it has dependent rows. Okay, so let's say, for example, now I will delete from customers where customer underscore ID is equal to 1001. Okay, if I'm deleting this row, what will happen? So first of all, when I try to delete, it is going to throw an error. So let me show you again. When I try to delete, it says there is a, so this foreign key sales customer, you can see that sales table customer violated a child record found. It clearly is telling you that there is a dependency and I cannot delete this record and it will exist. It actually failed to delete. Okay, it is not going to delete this customer record. Okay, now what if we try to delete the second one? Okay, second one does not have any sales, but it has dependent contacts. Okay, what it is supposed to do actually, if it has dependencies, it is supposed to stop us. Okay, what we'll do, we'll try to delete this row and see what happens. So it says one row deleted. And do you know why it got deleted? First of all, we will look at the output to see what is remaining in the tables. Okay, so here you can see the 1002 is removed along with all the dependent 1002 records for contact numbers is also removed. So now what happened is when I asked it to delete 1002 customer from the customer table, all its dependencies from customer contacts is also removed. The reason it removed that was on delete cascade. Okay, now where do you implement on delete cascade and where you should not implement? Let's say, for example, sales. If you have a sale, then you will never delete that customer because it's a valid customer. Keep it. Okay. But let's say there are some tables where you don't care about whether to keep it or not. What you'll do is you'll implement this on delete cascade. So coming back to on delete cascade, don't implement on delete cascade just because it is there. You have to understand the implication. Here, it never told you that it deleted other rows. It is only telling you that there is a master row I deleted. So it is not going to warn you saying, oh, I'm going to delete from 10 other tables because there is on delete cascade implemented. So you have to be careful while implementing on delete cascade. There is also on update cascade. I didn't talk about on update cascade. Now, what does that mean is what will you do if your master record gets updated? Will you make that update happen in all the dependent tables? Okay. One more thing I want to show you here. We created several tables here, like say customers, products, sales. Understand that your customers table can keep on changing, meaning a customer says, okay, my phone number changed, let me call and change it. I want to change my email ID. I want to change my name. My name is not written correctly or spelling mistake, right? Customers table can always change. Customer contacts can always change because they can call and say, hey, this phone number is wrong. So let me fix it. Now products, you see the products can also change because let's say, for example, first time we said we are selling milk, but second time we say, oh, now we have two types of milk. So let's say hood milk and garlic milk. There are other type of milks. Let's say 2% milk, 5% milk. So this information can keep changing. But remember that once you do a sale, that sale information doesn't change. So if you went to Amazon, you did some purchase, that doesn't change. Only thing changes in the sales table is when did the product got shipped, or let's say, for example, if you asked for refund because you're not happy with the product, then something changes. But your sale itself, the point of sale, does not change. Okay. So depending on that, you come up with this update cascade and on delete cascade. But in any case, what we did in the today's class is completely reviewed all available constraints. How do we use them? What are the restrictions? What kind of errors do you see? Um, we are actually getting closer to doing some really interesting stuff with tables. Now, this is first time we introduced something called dependent tables, and we said, okay, primary key, foreign key, how do you reference? There is a lot more, but what we'll do tomorrow is we'll try to see how to do the default values for columns. We'll do some column table aliases, and we'll start working on joins. Joins is a big topic we should really focus on. So what I'll do for now, I will just commit these changes. I haven't explained commit, but we'll get somewhere and we'll explain commit later on. So for now, if you don't have any questions, that's the end of class for today, and we'll continue tomorrow evening.